In our first video for the chapter, we can do better than that. In our first video for this chapter, we talked about energy and temperature. We defined both, showing how energy is the ability to perform work on an object, and temperature is a measure of the kinetic energy of a substance. Now, we're going to turn now to heat. Heat is perhaps one of the most important concepts in meteorology. It is because of heat that we have weather in the first place. When you break everything down to its most basic explanations, it comes because of differences in temperature, in other words, heat. Now, let's actually define heat here. So, I remember when I was young thinking of heat, like if we were by a campfire or something, hold out our hand, we'd say we're getting hit by a wave of heat, as if it's a substance that's coming in and hitting us. Not quite true. Not quite the best explanation. Here is a better definition of heat. Heat is energy in the process of being transferred from one object to another because of a temperature difference between them. The example of the campfire is hot. Relatively speaking, I'm colder than the fire, and so there's a transfer of energy from the fire into my hand. That's the wave of heat that I experience. Here's perhaps another example that we'll talk about more later on in the video too. If you have a warm drink, say a warm cup of water, you want to chill it, you want it to be colder, you grab a handful of ice cubes. Okay, warm water, warm means that the temperature is higher, meaning you have more energy in that water. And then ice cubes are colder, so the temperature of the ice cubes is lower, there's less energy. If you put the ice cubes in the drink, then you have a difference in temperature between the warm drink, high energy, and the cold ice cubes, low energy. And so energy is going to transfer from the warm drink into the cold ice cubes. That is heat, that transfer of energy. Okay? Now, hold on to that example. We'll talk about it again in just a second. There are two forms of heat. In other words, two results that can happen due to this transfer of energy. The first one is called specific heat. This is heat that results in a change of temperature. In other words, two objects that are at different temperatures, energy is going to transfer from the hot to the cold, and the result is that the two objects change their temperature. Remember that warm glass of water with the ice cubes in it? What happens to the water after heat occurs, after energy is transferred? Well, the temperature of the water drops. It gets colder. That is specific heat. Okay? Transfer of energy resulting in a change of temperature, cooling your drink. Now, let me introduce you to the idea of heat capacity. This is essentially how much energy it takes to heat 1 gram of a substance by 1 degree Celsius. Now, water is one of the most common common elements that we deal with. And so we're going to talk specifically about water first. So if we take the amount of energy it takes to heat up 1 gram of water by 1 degree Celsius, that is the definition of a calorie. 1 calorie is the energy needed to warm up 1 gram of water by 1 degree Celsius. Okay, that is an example of heat capacity. Over here in the table on the left, I have a number of other objects that we have the heat capacity for, or the specific heat constant is another term for that. Water, 1 calorie per gram degree Celsius. That's what this number is here. Whereas wet mud only takes 0.6 calories to heat 1 gram of water by 1 degree Celsius. Sorry, excuse me, I said that wrong. 0.6 calories to heat 1 gram of wet mud by 1 degree Celsius. I gotta say that right. Ice, it only takes half of a calorie to heat up 1 gram of ice by 1 degree Celsius. So you can actually heat up ice faster than you can normal water. Interesting little tidbit there. One thing I want to point out here, though, is that since it only takes half of a calorie to raise the temperature by 1 degree Celsius, then with 2 calories, you can raise, excuse me, I said it wrong again. I am so sorry. Half a calorie to raise 1 gram by 1 degree Celsius, then a whole calorie, twice the amount of energy, will raise it by 2 degrees Celsius. Sandy clay, it only takes a third of a calorie to raise 1 gram of clay by 1 degree Celsius. Since it only takes 1/3 of a calorie, then a whole calorie will raise the temperature by 3 degrees Celsius. Granite down here takes 0.19 calories. That's roughly 1/5 of a calorie. If you do 1/5, that would be 0.20. So I'll show you how close that is. So since it takes 1/5 of a calorie to raise 1 gram of granite by 1 degree Celsius, then a whole calorie will raise it by 5 degrees Celsius. Okay, is there a good application of this? Yes, there is. Good example, if you're cooking in the kitchen with a wood spoon versus with a metal spoon. You may have noticed that if you cook with a metal spoon, after a while, that metal spoon gets really hot on the stove. It's because it has a very low specific heat. It does not take too much energy to raise the temperature of metal. So, since it doesn't take as much energy, then that spoon can heat up very, very fast. Wood, on the other hand, has a very high specific heat. It takes a lot of energy to raise its temperature. And the result being that you pump in a lot of energy into wood, its temperature is only going to rise up a little bit. And thus, this wooden spoon stays cooler longer. Okay, there's specific heat. Specific heat is the heat that results in a change of temperature. But remember, I mentioned there are 2 forms of heat. The other form is known as latent heat. This is heat that results in a change in the state of matter. So remember, we had our warm cup of water with the ice cubes in it. The water cooled down. That was specific heat. But now let's look at the ice cubes. What happens to the ice cubes? They melt. They turn from a solid to a liquid. That is latent heat because it resulted in a change in the state of matter. Now, very important point here are the different states of matter, or different ways that matter, the states of matter can change. All right. If you go from a solid to a liquid, that's known as melting, obviously. And if you go from a liquid to a gas, that's called evaporation. Going the other way, if you go from a gas to a liquid, that's called condensation. And from a liquid to a solid, it's called freezing. All 4 of these we've dealt with many, many times in our lives. And we've talked about since grade school. But something that actually happens quite frequently, especially in meteorology, is either going directly from solid to gas or from gas to solid. If you go from a solid to a gas, that's called sublimation. And if you go from a gas directly to a solid, this is called deposition. A good example of an object going from a gas to a solid is frost. With frost, you have water vapor that leaves little water deposits, ice crystals on the ground. And a good example of sublimation is dry ice. If you've ever played with dry ice, you can put dry ice on the counter. You see it evaporate, it just disappears, but you never actually end up with a puddle of carbon dioxide. That's because the boiling point of carbon dioxide is so low, negative, is it negative 160 Celsius? I'd have to look that number up again, so don't quote me on that. But it's such a low temperature that dry ice on the desk just goes straight from a solid to a gas. It doesn't even melt, just sublimates. Okay. Now, these two forms of heat we are going to see over and over and over in the course. Specific heat, we're going to talk about the changing temperatures of water on the earth. We're going to talk about changing the temperatures of air, so on. Latent heat, well, this is weather. We're talking about evaporating water, the condensation of water to make clouds. We're talking about deposition of water to make frost. This is a very, very important part of the entire course. So you will see this come again and again and again. So make sure that you understand these 6 different forms in which states of matter change. One point that I wanted to add to this, to both specific heat and latent heat. If you add energy to an object, its temperature will rise. If you take energy out, the temperature will drop. That's when we're dealing with specific heat. Right? But if we're dealing with latent heat, then we talk about states of matter instead of temperature. If you add energy to the substance, then you're going to go from solid to liquid, liquid to gas, or straight from solid to gas. But if you remove energy, release it to the environment around it, then you're going to go to a lower state of matter. Go from a gas to a liquid, or a liquid to a solid, or straight from a gas to a solid. All right? So if you add energy to the object, it's going to go to a higher state of matter. If you remove energy, it's going to go to a lower state of matter. All right, in the next 3 videos, I'm going to show you how this heat occurs. So we have the warm water with the ice cubes. How does that energy actually make the transfer from the water into the ice cubes? And we'll talk about that in our next videos.